Welcome, everyone. My name is Arash Norimand, and I'm here with Dr. Alison Oliowski from the Ready Lab in the Faculty of Applied Science and Engineering from the University of Toronto. Our lightning talk today is going to be about revisiting the suitability of conceptual design with computer-aided design tools specific to a generational lens perspective. More importantly, what we're going to be talking about is the value of computer-aided design tools in conceptual design and the lessons to be learned for engineers in the product design space.
This lightning talk was inspired at last year's DTM conference, where I saw a presentation by Stephen Lindbergh and Matthew Campbell called How the Design of a 3D Printer Bridged Engineering Design Processes and the Agile Software Manifesto. In this talk, the authors argued that in order for hardware design to shift towards the agile way, conceptual CAD, where quick digital prototypes were possible, was a necessary element. The reaction from the audience at DTM was to remind the authors that the literature has shown that CAD is not the right tool for conceptual design work, and that it leads to various negatives, including fixation. I found this talk particularly interesting because my research group is studying what we call Cloud Collaborative CAD. This is a new type of CAD software, sometimes described as being Google Docs meets GitHub, which is highly collaborative, also really low barriers to entry and highly accessible via a simple web browser. You may know commercially available cloud collaborative tools such as Onshape or Autodesk Fusion 360. Now, I don't think the community debates whether these tools are appropriate for embodiment design and detailed design, but reflecting on what I heard in the presentation last year, I wondered if it is really not appropriate to use these modern cloud collaborative tools for conceptual design. In fact, my research group is currently conducting interviews on the design process with professional engineers from industry, and we've heard a couple of times, unprompted, that these professional engineers are using collaborative CAD tools for conceptual design in industry. One, for example, used Onshape in combination with a whiteboard during a conceptual design sprint, and another talks about how it's useful to quickly put your ideas together in a 3D model. In general, the literature agrees that CAD, as a tool for creative problem solving, has the downsides of premature fixation, circumscribed thinking, and bounded ideation, and therefore recommends sketching as an alternative. However, it's important to critically reflect on this literature and ask a few questions. The first question I ask of the CAD for conceptual design literature is, are we actually talking about the same task? Concept development involves not just concept generation and ideation, and is not always a clean sheet exercise. Further, creativity is not always the number one priority of a conceptual development task. The second question we ask is about the effect of technological and digital fluency on CAD behaviors. Digital natives are the generation who grew up in the era of ubiquitous technology, and these individuals have now reached senior mechanical designer roles, with expertise worth studying in industry. We wonder if engineering designers of the future, with experience and familiarity with Google Docs, Minecraft, and TikTok, will show these same behaviors of fixation, bounded ideation, and sunk cost effects.
With the motivation for this research understood, it's time to now revisit the question of the applicability of CAD for conceptual design. Specifically, there are updated tools and a new generation of designers entering the industry, and it's time to consider digital natives as expert designers in the industry and pay more specific attention to the generational differences between new designers and the former incumbents. We actually created a survey to collect preliminary data to explore this question and to see what types of insights could be distilled going forward. The question to be asked now is, do younger designers' views match literature? Younger designers now have a greater proclivity towards technology usage as opposed to more senior designers, and have occupied a much larger portion of industry and academia and are going to continue to occupy more of this space. However, they are currently underrepresented by the current body around CAD usage research. So we actually distributed a survey to the global product design community via social media. The survey has 4 parts. One is around demographic information, then around design infrastructure and respondents' workplaces. Third is around the design process utilized by these respondents' organizations. All of this culminating in the actual data around usage and opinions of CAD value in conceptual design. The results actually tend to match our initial inclination. Junior designers prefer CAD more than senior designers in conceptual design. Specifically, the senior respondents tend to prefer to use sketching as a means for conceptual design, whereas junior designers tend to prefer sketching and CAD with a slight preference to CAD usage. This is particularly interesting because what it indicates is that there's this dichotomous shift towards younger designers using technology and its greater features throughout the conceptual design process. With the research conducted, it's important to talk about the limitations in our future work. One is that the majority of respondents were within the same role, particularly from the machine design, medical device, and automotive industries. As well, our data set is skewed more towards younger generations, and the majority of our responses are North American. To address this going forward, it will be important to distribute the survey across more platforms and to incentivize more survey filling to get more numerous, diverse, and statistically significant results. In addition to this, conducting qualitative interviews will help us get a more holistic understanding of how respondents use CAD from a qualitative perspective. In addition to this, conducting experiments to see how different CAD utilizations result in end product quality will allow us to see a tangible result and how that compares to our heuristic understanding of CAD. So with this research, what are the next steps and implications? One is to acknowledge that CAD is evolving very rapidly with new features and improved capabilities being added. Engineering designers now are becoming more techno-literate and comfortable with digital tools. As a result of this, it's time to revisit the assumptions of the downside of CAD in conceptual design and also consider the implications of conceptual CAD both as teaching in engineering schools but also as an industry norm. Thanks for listening, and we'd be happy to take questions now.